Hi everyone, welcome to my channel. This is Quantitative Unicorn. If this is your first time tuning into my program, I want to let you know that all the demos and data files in my program are free to download. You can find these files by clicking the link below the video. And if you are a returning viewer, I hope you have taken my advice and spent some time practicing the code we covered in our last episode. And just a kind reminder, this course is meant for educational purpose only. The data and information presented in this video is not investment advice, okay? And please subscribe to my channel, like the video, and click the bell icon on to receive the latest updates. Thank you. In the last video, which was the Association of Random Variables episode, our emphasis was on explaining these concepts in statistics and introducing their applications in the finance field. Considering that you now have a good understanding of the above content, today we will do a detailed breakdown of the Python code for each module. By gaining a deeper understanding of the application of Python code in these specific scenarios, you will be able to better grasp the topic we are learning and lay a solid foundation for future learning. How exciting! Well, let's get started. Let's start here, the second cell. First, we need to import a data set containing information about the housing market. The data set is stored in a CSV file named housing CSV and is read into a pandas data frame using the pd_read CSV function. The index column equals to 0. This argument specifies that the first column of the data set should be used as the data's index. Should be used as the data frame's index. Sorry. So here, let me show you an example how this works. Suppose we have a CSV file called data CSV that looks like this. And if we load this file into a pandas data frame using the read CSV function like this, then the resulting data frame will look like this. And in this case, the data frame has been automatically assigned a default index that consists of integers starting from 0. However, if we want to use the name column as the index instead, we can specify index column equals to 0 when we call read CSV like this. And then the resulting data frame will look like this. As you can see, the name column has been used as the index instead of the default integer index. This can be useful when we want to refer to rows by their names instead of their positions in the data frame. Okay, I hope this clears things up a little bit. And let's get back to our housing data frame. The data frame contains several columns, each representing a different characteristic of the Boston suburb housing market. These columns are labeled LSTAT, INDUS, NOX, RN, and MEDV. The housing head function is called to display the first 5 rows of the data frame, allowing us to visually inspect the data and check for missing or incorrect values. Overall, this code imports a dataset containing relevant information about the housing market and creates a pandas data frame, which can be manipulated and analyzed using various Python functions and techniques. The housing covariance function calculates the covariance between columns of the housing data frame, which contains information about the housing market. Covariance is a statistical measure that describes how two variables change together. And in this context, a covariance can help us understand the relationships between different characteristics of the housing market. More specifically, the housing covariance function calculates the pairwise covariance between all the columns of the housing data frame and returns the results as a new data frame. The resulting data frame has the same columns and index as the original housing data frame, but the values in each cell represent the covariance between the corresponding columns. By looking at the values in the resulting data frame, we can see which characteristics of the housing market are positively or negatively associated with each other. For example, a positive covariance between LSTAT and INDUS would indicate that areas with a higher percentage of low status population tend to have more non-retail business acres per town, while a negative covariance between INDUS and MEDV would suggest that areas with more non-retail business acres per town tend to have lower median home values. Overall, the housing covariance function is a useful tool for quantifying the association between different variables in the housing market, allowing us to gain insights and make informed decisions based on the data. The housing covariance function calculates the pairwise correlation coefficients between the columns of the housing data frame. Correlation is a statistical measure that describes the strength and direction of a linear relationship between two variables. In the context of the housing market, correlation can help us understand how different characteristics of homes are related to one another. And more specifically, the housing correlation function returns a new data frame with the same columns and index as the original housing data frame, where each cell contains the correlation coefficient between the corresponding columns. The correlation coefficient ranges from a -1 to +1, where a value of -1 indicates a perfect negative linear relationship. 0 indicates no linear relationship, and 1 indicates a perfect positive linear relationship. By examining the values in the resulting data frame, we can see which pairs of characteristics have a strong positive or negative correlation. For instance, a high positive correlation between RM and MEDV indicates that homes with more rooms tend to have higher values. In contrast, a high negative correlation between LSTAT and MEDV suggests that homes located in areas with higher percentages of lower status residents tend to have lower values, which is obvious and which is also sad. Overall, the housing correlation function is a powerful tool for understanding the relationships between different characteristics of the housing market. By using correlation analysis, we can gain insights into how different factors affect home values, which can inform decisions about buying, selling, and investing in real estate. The scatter matrix function is a part of the pandas plotting module, and it is used to create a matrix of scatter plots that visualize the pairwise relationships between all the columns of a given data frame. The housing data frame contains various characteristics of Boston suburbs real estate market, and the scatter matrix plot will enable us to visualize how these characteristics are related to one another. In this code, we first import the scatter matrix function from pandas plotting. We then create a scatter plot a scatter matrix plot for the housing data frame where fixed size specifies the dimensions of the plot in inches. The resulting plot will be a square matrix of scatter plots, where each plot will show the relationship between a pair of columns from the housing data frame. The diagonal of the matrix will contain histogram plots that show the distribution of each variable. The off-diagonal elements will contain scatter plots that show the relationship between pairs of variables. By examining the scatter matrix plot, we can gain a deeper understanding of the relationships between different characteristics of the housing market. For example, we can see whether there is a linear or nonlinear relationship between two variables, whether there are any outliers or data points with extreme values, and whether there are any patterns or clusters in the data. Overall, the scatter matrix plot is a powerful visualization tool that can help us gain insights into the relationships between different variables in a dataset. It can be especially useful in exploratory data analysis, where we want to get a sense of the overall structure of the data before proceeding with more sophisticated analysis. Here comes our last code for today. This code creates a scatter plot that visualizes the association between two variables, the average number of rooms, RM, and the median value of owner-occupied homes in thousands of dollars, and MEDV. Housing is the pandas data frame that contains the data to be plotted, and the plot is the pandas method that allows us to create various types of plots from a data frame. The first argument specifies that we want to create a scatter plot, and the second and the third argument specify which variables to use for the x-axis and y-axis, respectively. In this case, we want to plot the relationship between RM and MEDV, and fixed size sets the size of the figure in inches. By running this line of code, a scatter plot will be generated where each point represents a term. The x-axis will show the average number of rooms in each term, and the y-axis will show the corresponding median value of owner-occupied homes. The scatter plot allows us to visually inspect the relationship between these two variables. For example, we can observe whether there is a linear or nonlinear relationship between RM and MEDV, whether there are any outliers or data points with extreme values, and whether there are any patterns or clusters in this data. By examining the scatter plot, we can make preliminary inferences about the relationship between the average number of rooms and the median value of homes. As we can see here, there is a positive association between RM and MEDV, which suggests that homes with more rooms tend to have higher values. However, we would need to perform more rigorous statistical analysis to determine the strength and significance of the relationship. If the parameter kind is not set to scatter, it could be set to other plot types such as line, bar, hist, pie, area, box, KDE. And here are some examples of different kind of parameters for plot method. I suggest you try all of them so you can get a better understanding of the syntax. Overall, scatter plot is a useful tool for visualizing the relationship between two variables and can provide valuable insights into the data. And congratulations, folks. That's all for today's tutorial. And remember, practice makes perfect. So keep working hard and experimenting with what you have learned. And if you still have any questions or feel that you have not fully understood or need more explanations or examples from me, please express your needs in the comments section. I am more than happy to help you out. And speaking of comments, I am always open to your feedback and suggestions. So if you have got any thoughts on how we can make this program even better, please don't be shy about sharing them. And if you haven't already, I would love it if you could subscribe to my channel to stay updated on my latest videos. And if you have friends or family who would also appreciate the knowledge of building stock trading models in Python, please feel free to share my videos with them. I truly appreciate your support, and I'm excited to continue sharing more tutorials with you on my channel. Thank you again for your time. I wish you well and look forward to catching you all in the next episode. Goodbye.